Hello, and welcome to another FHIR for Developers tutorial video. My name is Gino Canessa, and today we're going to kick off on another exploratory series. This time we're going to look at FHIR and databases. This is something that a lot of people have requested. I will give a spoiler alert slash disclaimer, which is to say it depends. There's going to be a lot of choices here, a lot of different options. We'll go through and examine a lot of them and try to look at some of the pros and cons, but the exact details of what's going to make the most sense for your architecture are going to vary greatly depending on your use case, on your business details, on all these other things. And so this will not be a video series that tells you this is the one true way to do it, because to my knowledge that does not exist. So with that said, let's jump right in. To start, I want to look at the patient resource. And this is because it's a good example. It's something we can all kind of relate to intuitively. And it's a good example of some of the challenges we face and kind of highlights why this comes up. So to start with, I'm just here at the FHIR webpage on release 4 still. That is the current release, looking at the patient resource. Now, a patient is, as we can see, demographics and other administrative information about an individual or animal receiving care or other health-related services. So you can think of human patients, you can think of veterinary patients, different things like that. It is the being receiving healthcare or other related health services. And there's some examples here. One of the things I like is that also when we talk about a patient, in a lot of ways we're just talking about a person for a lot of use cases. Obviously we want to make sure that other things can be handled, but if you're dealing with veterinary, you're probably accustomed to that in your space. But it's something that a lot of us have dealt with. A lot of examples when you're starting out with databases, when you're starting out with learning languages, different things like that, we'll cover some sort of mapping with a person, a customer, addresses, different things like that. And that's a lot of the same information that's here because this is demographics and admin. And so it's pretty common across a lot of different use cases for the most part. So we start off looking here and we have the patient resource. So already in, again, I'm going to jump around a little bit between kind of relational database systems and NoSQL systems, document stores, graph databases. We'll try and touch on a lot of these things. But in a lot of the context, I'm going to be thinking of a relational database because that is, again, what most people ask about and what I've used the most historically. So you can already see the first thing you're going to be thinking is like, oh, I can have a patient table and I'm going to keep some information in it. If we start looking at the elements, and again in FHIR these are called elements, and I'll try to make that distinction when I'm talking about the FHIR version, which is the element, and in a database it's usually a field. So I will try to make that distinction. But we have a great element to look at, which is active. This is a great element because it's 0 or 1 value. It is a Boolean, and that's it. It's whether the patient's record is active or not. So we can map the element to a field very easily. We can have a Boolean field. All databases support some sort of Boolean. We can have it be nullable. Most databases, again, have some concept of nullable. And that's it. A nullable Boolean, single value, true, false, or not present. Very straightforward, very simple, and it's the kind of thing that maps great. The next element here is the name. And again, we think of people's names, usually think of first name, last name, different things, different modeling. There are a lot of different choices for modeling that. But we have a few things we do want to look at. First is 0 to star is the cardinality. So if you've been working with FHIR, this is the way of signifying that it could be an array. So a person can have multiple names, which makes sense. You think people change names, and your medical record should reflect many of those, not necessarily all of them, depending on what's going on. But then we can also see that the data type, instead of a nice Boolean, and again, a hint here in the type system in FHIR, is these lowercase values like Boolean, code, and date are kind of the simple data types. And then when they're uppercase, they are complex data types. So if we go look at human name, which we know is going to be a complex data type, we can see that it is. It has a lot of potential data. It has different uses, text hints, family names, given names, which can be arrays, prefixes and suffixes, which could be arrays, a period when the name is or was in use, all these different things to say that it is part of the name. And this is great. It's very detailed information so that you can say this person came in, they came into the emergency room and they were referred to by this nickname, and we wanted to log it because their visitors are all asking for them via their nickname, which is just going to be some text. Versus, this was someone's maiden name, which was in use over a certain period of time, so that we know this was their name in old records, observations, different things like that. If we have their record from another system and we're looking for old things, we need to ask for a different name. So there's a lot of detail in a name when you really break it down, but all this has to be modeled. And so in kind of traditional database thinking, you would likely want to normalize this data so that you have a patient record, a patient table, and now like a name table, and then you're linking back and forth between them. Again, in FHIR, this makes sense when you think about this is being used to model the entire patient and transfer it in one shot. This nice hierarchical data store is great, but it does face some challenges when you try to flatten things out and index them in different ways. So there we touched a little bit on the complexities of the name, and we have the same thing with arrays. So not only is it that you can have all of these different elements, which we could just expand into our table, but you could have 0, you could have 1, you could have 10. And so it's very complicated to start saying, well, you're not going to have use 01 through use 10 and text 01 through text 10 and things like that. And especially when you start nesting into further ones, given 0, name 01, given 01, things like that, that you start needing arrays inside of arrays. I will say, again, without jumping ahead too far, but most databases have ways of handling this better nowadays. And so this is just purely from the kind of old school traditional database modeling questions. Another interesting one is when we look at elements like deceased or multiple birth. These are interesting. Again, they have just 0, 1, so that's nice that it's just present or not. But these are what are called choice data types in FHIR. And you see here, deceased can be a Boolean or a date time. Multiple birth can be a Boolean or an integer. And what this means is that in some systems, you're just going to know true, false. And in some systems, you're going to have additional data. So one system might just tell you if a patient is deceased or not, and other ones will tell you the date time that the patient became deceased or was coded as deceased. Same thing with multiple birth. Some system will say yes or no, was this patient a part of a multiple birth? And some will say, well, this was one of 3 in a multiple birth, one of the triplet. Again, it can be complicated when you start modeling these things out, because if you wanted to put this in a single element, Boolean and integer are a great example of data coercion that can go awry, which is to say if you store an integer in a database but you cast it to a Boolean, most languages will just treat 0 as false and anything else as true. Again, there's variations, negatives versus positives and all kinds of things. But generally speaking, an integer to a Boolean cast is going to be valid. And so you need to make sure you're either separating things out, that you're normalizing things on the way in, or handling it in some form. Just saying I'm putting multiple birth and shoving some piece of data in there is not likely to go well. Another one kind of interesting modeling point you have to address are what are called backbone elements. And so this is kind of like an embedded data type, for lack of a better phrase. So we can see that what happens is we have this contact, which is a backbone element. And contact has its own set of elements, and we can see those here. And you can have 0 or more contacts. So it's really a way of saying contact could be its own data type and all these things, but it's specific patient contact. So it wouldn't make sense to define a whole data type for that in FHIR. So there's just a bunch of elements that are collected in this backbone element, and that's essentially a data type. So it's just like expanding human name, but we're just expanding it here. And again, these things can all nest. So you can see here, contact can have a human name, can have their own contact points, can have multiple of those, can have different kinds of relationships, all of these things. So there's a lot of nesting, a lot of potential for arrays versus scalar values, all of these types of things. Another important point I want to touch on are references. And so here we can see there's a couple, and there's a few other ones like here in contact and down here in link. But we can see that there's a general practitioner link, a reference. There's a managing organization reference. And these elements are of the FHIR reference data type. So same thing if we want to look at those. We can see that references aren't just a nice key or something like that that we would want to use in a database. It's its own structure again, and it has a bunch of different fields which may or may not be present. So it can have a literal reference, which is a relative internal absolute URL. I will note that the data type is a string, and that's what it was defined as historically, and it's not worth trying to change it. You can also have a type, which may or may not be present, which is telling you that it's a patient or an organization or whatever it is. You can have an identifier, which again is another complex type. You can have a display string, all of these things, and it's saying that these are just what you should be able to expect. There should be something there, but we don't know what it is. And so again, when we want to model this in a database, it can be pretty complicated. But the point is that here we have a foreign key, essentially, that could point to any of several other tables. Same thing here with link to other. It could be a patient, it could be a related person. And so it kind of gets, if you're trying to model this into a traditional database, it's pretty complicated to say how you're going to actually map all these things. You might want to split these out and do reference organization, reference practitioner, reference practitioner role. But again, you can have multiple of these. And so you probably need to invert them and do them the other way so that you're looking things up in organization, practitioner role, and coming back. These are the kinds of things that you're going to want to be aware of. Again, I can't necessarily say this is the one true way to do it, but we'll get through some of the examples of how we can do these things. So you can see there are a lot of challenges here that have to do with relaying the FHIR models into what we can put in a database. Switch over to some notes here. And I was typing these out when I was trying to do this as I was typing it out in real time the first run through on a test recording. And I decided to just leave them typed in so that I can go through them instead of trying to type as I go and remember all of them. So really, we have a couple of choices when it comes down to how we're going to put this data in the database. And again, there are more, but generally speaking, I like to categorize as we can use FHIR as our database schema, or we can keep the FHIR data serialized somewhere, whether a database field or a file or something like that, and we can just grab the pieces we want. And those are kind of the two general categories I'm going to break these into. And then it will vary a lot, kind of what you have to do depending on what type of database you're using. Again, I'm going to look at some relational databases. I'll probably use Microsoft SQL Server because I am employed by Microsoft. And then we'll look at some NoSQL databases for a document store, probably like MongoDB, pretty common. Maybe look at Cassandra. We'll look at some sort of graph database, things like that, and we'll jump into a few different ones that we'll set up and do some code behind. So again, both of these are going to have pros and cons, and it's going to depend a lot on your architecture and what you're trying to do. So in both cases, the first thing you're going to want to do is identify your key data. And what's to say is that if we are looking at patients, right, it's great that we're storing patients, but how am I finding the patients I want? Is it always just by ID? Am I using this from another business system that knows the ID and I'm never actually searching for data? Okay, well, that changes, again, what I want to do. Because in a lot of cases, if I'm using a file store, I don't even need a database. If I know that the system's always going to have the ID on a request, I could literally just have this in a file system or in a blob store referenced by the ID and just grab the data I want and parse the stored data into my models, and I'm good to go. If it's people searching, they might be searching by name, address, recent encounters, different things. You're going to need to start figuring out what those things are and make your decisions based on that. So if we want to look again at FHIR as your database schema, in a relational database, you're going to start looking at kind of these layers. What are your tables? What are your fields? How are you normalizing? What data are you replicating? Again, this is going to be pretty dependent. We'll go through and look at a couple of databases in future videos here so that we can kind of compare and contrast. Some of them, a lot of databases nowadays have direct JSON support, so that you can just insert JSON and as a row set or as a collection or different things like that, and have it build the schema from there. And actually, that does remind me on one point I forgot, looking at the FHIR model, which I'm going to jump back to because that reminded me of it, is something that's not really listed here are extensions. And that is so easy to gloss over that I missed it. I did want to make sure I bring that up, is that here it's defined on the resource because there's a specific element called extension that's actually on domain resource. And you can see extensions are the extension data type. It's some sort of URL to identify what the extension is, and then some sort of value. And this can be any data type. There's a whole list here of what it can be, but you can even have complex extensions that are extensions inside of extensions, all kinds of things. What's interesting to note is that any element in FHIR, with a few exceptions, very few exceptions, can have extensions. And that's because FHIR doesn't know everything for every possible use case and wants to make sure that if you have data you need to keep track of on a patient's birth date, you can do that. And you can just add an extension to birth date and keep that data with it. How it's serialized, in JSON, for instance, you would have a sibling element next to birth date, underscore birth date, which is the actual extension, and it's actually extension, and it can have an ID, different things like that. But suffice to say that anything you have here can also have extensions that can point to other data types and keep nesting down pretty indefinitely. So coming back to, and that's why it was relevant here, is when you start determining all of this, if you are manually mapping elements into schema, you're going to have some trouble with extensions. I mean, there's really no other way to put it. It's going to get complicated very quickly. So overall, I kind of shy away from this approach. I put it first because it's kind of where a lot of people start. You say, oh, I have a FHIR model. I want to use it as my database model. But it's very difficult in practice, in my experience. As you're trying to do that, you need to still define your indexes. Again, if you're just putting a list of patients, if you're searching by name and don't have that indexed, that will be a slow process. So you still need to define all of those. You need to make sure your code is mapping everything back and forth between the database, because in this case, when someone asks for a patient or when you get a patient, you are manually doing that. A lot of times people say use an ORM, EF Core, Dapper, different things like that. But the FHIR models are pretty challenging, again, for a lot of the same reasons we were just talking about, that these are things that are not present unless they are, and then there's a lot of circular references and things like that. Extensions can have extensions in them, and how does that actually get mapped into a schema? It's also worth noting that if you're using an ORM on top of FHIR SDK or something like that, changes in either the SDK or the FHIR version can break your system. And that's to say that if there are internal modeling choices that are different between versions, which normally you don't care about because you're just using the code, if you're mapping that via an ORM that's not directly supported, you can have a problem. And that's because generally these SDKs aren't meant to do that. The SDKs are to give developer convenience on top of these other things, and the serialization formats are really where we're doing things. Which does mean that this is a pretty good way to store things if you're using a document store, as an example. Same thing, you still do need to think about your models, schemas, stores, databases, whatever language your particular database is using. You still need to think about how you're configuring all those things, how you're storing them, where you're putting them, what kinds of filters you need. Does it support indexing? If so, defining those types of things. And you can see we have kind of this example pros and cons, and actually these should all be one more in because this is for a document store. But you can see that there are a lot fewer design decisions. Like if we're just storing a patient, we put it in our space for patients, and we're done. If we want to search for a name, we are looking for .name and letting the database do the work behind. And in general, less transformation, less code. I am always a fan of less code because that is less you have to write, less you have to maintain, less you have to fix when there's a problem. But there are trade-offs. So in this case, for instance, if you are looking for nested data, it has to be indexed, right? If you have a lot of records and you want to do this, now obviously if you have very few records, full text index the whole thing, who cares? But the reality is that time and storage, compute cost, different things like that. If you're doing full text indexes, if you're looking at nested arrays of complex objects, there's a cost there. And if you don't want to pay that cost, then you're going to be paying it on your queries, because same thing, it's going to have to go and search data. It can be costly, CPU time. It can be slow performance, costing you users, different things like that. And also finding some elements can be hard. Again, especially when we start talking about extensions, you have to do things like look for, patient.name, in this case, the extensions are going to be an underscore name, .extension, where the URL is this particular URL, and grab the sibling value code, because that's the thing I'm looking for. That can be pretty difficult to describe in some of these query languages. So again, there's going to be pros and cons on all these things, and that's where the trade-offs come in. So on the other side of the spectrum, we have keeping the serialized data in a database field or in a file. And I put these together because really all we're doing is saying, do we want these inserted into the database so the database is storing them, or do we have some sort of blob file system store where we're putting files? The initial steps are the same. We still need to identify our key data. We still need to look at, if we're looking at a patient, what are the kinds of things we need to know? Do we need to know their name? Do we need just the IDs? Those are going to inform how we're going to build our system. Again, same thing if we're looking at databases and file systems. How are we handling replication, failover? What are the costs associated with storing in one or the other? Do we have a document store behind and a relational in front for searching, or a graph in front for searching? All these different types of things that'll play through in your decision-making process, and we'll play with in some future videos. Here I kind of went through the same thing, and in this case, again, highlighting a relational database and a NoSQL like a graph database. You can kind of treat them the same way. You're essentially using them as a search or index component, and then you're going to load the actual contents from some sort of blob, whether it's in the database or a file system. And again, things look the same. Just like we were talking about up here, you just determine what formats you're storing things, what information you actually need, how much do you normalize it, define your indexes. I did want to note that ORMs here are a lot more useful. If you say my patient has 10 elements on it, 10 fields on it that I want to look at and index, I can build that out. I can build out a patient table and a patient name table and just make some custom models that will point to the different pieces of data. But I do want to note that when you're doing this, you do have to be careful with data synchronization. And that is saying you want to make sure that your database matches your file store, or if you're storing the blob in the database, that you know what's happening. And people do play tricks here in production systems even, doing things like if you are updating data that's in the index, I'll update the database field but not update the file. And then when you read it, I'll reapply those updates every time. Different things like that. Again, there's a lot of possible space here, but you just want to make sure you're aware of it. Something I didn't discuss here as well that I'm not really going to get too far into is version management, which is to say major FHIR versions. Right now there's published DSTU2, STU3, R4, and right now we're working on consolidating everything for the ballot of R5. And so it's something, again, to be aware of. Is your system going to be just on one version of FHIR? Are you going to migrate? Are you always going to have the one version you actually support and your data will migrate from one version to the next? Are you going to offer different views into that data? Things like keeping files in a file store. Your indexes don't change between versions necessarily. If your use case says you're searching on a patient name, the actual contents of the patient record don't matter as much because you're extracting them and putting them back. But you need to be able to return things in the right formats. So again, there's a lot of space here that you want to be considering these trade-offs. I'm trying to highlight kind of some of the top end of those things without getting too far down any of the rabbit holes. So looking at the time, actually, I think that might be a good place to cut this video. So again, this is kind of the overview of what we're going to be exploring. In the next set of videos, I will set up some of the databases. I'm just going to set things up in Docker so that we can build systems that are reading and writing data so that we can make some of these comparisons. And I'll try to set up, again, an array of relational and non-relational databases so that we can kind of explore what some of those trade-offs look like. If the video helps, please like, subscribe, etc. And any feedback is always welcome. Thanks. Cheers.